Hello and welcome to the Art of Waterproofing. This episode relates to concrete curing, finishing and surface preparation. I'm also going to talk about how you also deal with steel and masonry structures during this particular episode. So let's just start at the beginning. You have a contract, a project that involves, let's say, a new concrete bridge. How long does the concrete need to cure? What sort of finishing techniques needs to be employed so that the waterproofing system that will come afterwards will get a good bond to the surface and there won't be any compatibility issues with that. So if we just start at the new concrete at the beginning. So typically when you're placing concrete, obviously the concrete is pumped in normally and it's vibrated and then it is vibratory finished or floated and floated normally using like a helicopter to float off to give it a uniform surface. Most waterproofing manufacturers or installers will request a smooth, uniform finish. In the UK, that's typically called a U4 finish. And a U4 finish is either a power float finish that's been abrasive blasted or a wood float surface. So what they're looking for is a uniform surface that's free of irregularities more than about 3 millimeters over a distance of about 5 meters. There is a standard for this. I'm not giving you chapter and verse here on U4. You can look that up. You can Google U4 finish and you will find a description of that which is quite clear for you to understand. So in terms of the finish, that's what contractors are really going to be looking for. If the finish is not to a U4 standard, if it's a lesser standard, let's say it's got tamps on it, it might have got footprints, there might be repairs, there might be honeycombing, etc., etc., then there's going to be preparation and cost required. So the point is that if you set out to do a particular finish, it will save you cost and time doing additional repairs later. Because things aren't going to change. The contractor will still want a U4 finish. So for the main contractors out there that are responsible for preparing the concrete, it's better to do it first time rather than coming along later and finding, oh, we've got some extra preparation to do. And again, it's going to cost you time and money, which is not good for any party. So yeah, work on a U4 finish. Steel, power float or wood float finish. Make sure that it's free of any blowholes on the verticals. Verticals should be an F2 finish, which is a fair-faced upstand or to your jersey barrier. Again, you need to be making sure there's no air holes, blowholes. They need to be, we call it bagging off, to make sure they're sealed properly. You need to speak to the contractor about whether they need a chase in the parapet. Again, some contractors need that, some contractors don't. Depends on the waterproofing system. A lot of the bitumen sheet systems need a mechanical key, so you'll need to put in a groove in the upstand. But if it's a liquid spray applied or hand applied system, generally speaking, they'll terminate to a taped edge, so they don't need the void in the upstand. But it's important to check and ask. So we've talked about the finish of the concrete in terms of the curing of the concrete. Typically on a C50 concrete mix, it's about 7 days from placement. But that can depend on the ambient conditions, the water cement ratio, and also things like curing agents that are used. But 7 days is a good rule of thumb. But the overriding factor is the surface moisture content of the concrete. And typically, most systems will accept anywhere between 6 and 7% as the high level. So if it's less than 6 or 7%, it will be acceptable. If it's more, then it won't be. It'll be too high in moisture and it will affect the bonding. So the contractor will come along, or the specialist will come along and do a moisture check, typically after about 7 days, to check that moisture is okay, and then he'll be able to apply his system. And that applies to vertical as well as horizontal surfaces. So that's the curing and the moisture content level. Curing agents are used in the industry as well as plastic sheeting. You need to check with the waterproofing manufacturer before you use a particular curing method to make sure it's compatible with the waterproofing system. There are water-based ones which have been known to be compatible, no problem, because they will degrade. But there are also silica-based ones that can leave a residue on the surface which will need removing. So it's extra work for the contractor. And they can cause delamination, you see. So check first. Check before you start placing these curing agents with the manufacturer, so there's no issue with compatibility. So I think we've covered now that the new concrete generally needs about 7 days cure, but the overriding factor is 6% or less. We've covered the finishing technique, U4, which is steel, power float or a wood float surface, uniform surface, and making sure that the vertical is an F2, free of any blowholes. Okay. And then the upstand itself, you need to discuss with the manufacturer whether or not they need a chase in the upstand. And we talked about curing agents. You need to check again compatibility. Water-based generally being okay. Resinous ones will leave a residue which needs removing, so which is not good. So that is the next section of this episode covering concrete finishing. Hopefully that's given you some insight into concrete world. Okay, now I'm going to talk about steel world. Okay, steel bridges are obviously different to concrete. They need different types of preparation. So again, if it's a new steel deck, then the steel will have been abraded, and normally a holding primer is applied to the steel, either in the fabricator or on site. The waterproofing manufacturer needs to check compatibility with that holding primer to check whether it needs to put another primer on, whether it needs to take the holding primer off, and whatever's suitable for that particular system. So steel, it's very important that if you're removing any holding primer, that you apply another primer within 4 hours, because it will start rusting again. So on steel, it's very important that the steps are done in the right weather conditions to make sure that the bonding is good. So in terms of the preparation, abrasive blasting or recirculatory blasting is the quickest and most efficient technique that I've come across over the years. It will abrade steel, it will remove any oxidization, remove any holding primers, ready for the new primer, the new system. The verticals will want abrading either using an angle grinder with a wire cut brush, or open blasting for upstands and intricate areas. Again, you need to prime up within 4 hours to avoid reoxidization. So that is a new steel structure. For existing steel structures, similar methods apply, but there'll be existing coatings on the bridge which will want removing. Generally on a steel bridge, there's going to be asphalt, gut asphalt or mastic asphalt on the surface, and there may or may not be a membrane of some nature. It might be bitumen based, it might be MMA based, or epoxy based, generally on steel bridges. So that they will want removing. So the asphalt is normally planed or pulled up with an excavator, and the existing coatings are removed using hand tools or mechanical means to get underneath the coatings to lift them off the deck. What you need to avoid is obviously damage to the steel. There's going to be bolts, there's going to be welded sections, there's going to be rivets. All of these on a steel bridge need protecting. They're part of the structure. You don't want to be taking off bolts while you're doing the preparation. So it is important you use the right method. The method relates to the type of system that's on there. So knowing that information before you start a project is very important. Finding out what thickness asphalt's on there, what coatings are on there, and what condition it's in. If you can get a sneak preview with a site visit to inspect, great. You can take a sample, decide how you're going to get that material up, what condition it's in, how well it's bonded, and all of these will determine what method and equipment you use and time to remove that particular material. So that is the world of steel, existing steel and new steel. I'm just going to go back a minute now to concrete preparation on an existing refurbishment project. And there are thousands of these around the world, obviously. It may be an extension to a bridge. It may be a re-strengthening of a bridge or just resurfacing of a project. So you're going to find on an existing bridge, obviously the asphalt, there's a waterproofing layer, a concrete deck beneath it. There may well be service bays that you need to treat. Might be pipe work in there, other bridge furniture you've got to deal with. Lots of different things you need to start thinking about, which will determine how you're going to prepare the surface and not cause adverse damage to the concrete. The last thing you want to do when you're preparing concrete is to damage it. If you damage it, you're going to be doing repairs afterwards. You might be causing structural problems to the reinforcement, exposing the reinforcement, etc., etc. So not a good idea. So same way for steel, make sure you try and do an inspection beforehand. Do check the as-built drawings to find out what's on there, what condition it's in, when it was laid, some of the obstacles that's on there. Forewarned is forearmed. Give you that information so you can prepare the right methodology, the right equipment, the right personnel as well on these jobs. A lot of these jobs are done when there's live traffic next to them as well, so you need to watch out for that. Whatever method you're using does not need to encroach onto the existing people and public that's using the road. So it's very important that you use the right method. So assuming we've done that exercise, we need to remove the asphalt. Typically asphalt will be, again, you'll check with the drawings, it may be 120mm maximum down to 50 millimeters. So the method of removing 120 and 50 are normally different. If you're plain 50mm asphalt, you might go into the deck, which is not a good idea. 120, obviously you've got plenty of room for safety. So again, talk to your contractor about safe removal of the asphalt and not planing into the deck, which is sacrilege. It'll cause major problems if you're planing into a deck. So once you've removed the asphalt, you've then got your existing coatings to deal with, and they can be treated. Again, it depends on the type of the system: bituminous systems, acrylics, polyurethanes, pumice systems. Generally speaking, they're going to be well bonded. In the summer conditions, it's more difficult than winter conditions. In winter, the materials are quite hard, certainly the acrylics and the epoxies and the bitumen based, so they'll be easier to remove. In the summer, the materials will start softening and they become quite rubbery, shall we say, and they tend to be more problematic to remove from the concrete. All of these things need to be taken into account when you're doing the preparation. So you're trying to remove them in a safe and methodical manner, not to damage the concrete, but to remove all traces of the existing coatings. There are companies out there that can use basically like tile strippers, stripping equipment, which are mechanical with a flat bladed tooth, like a ripper tooth. They'll get underneath the coating and they will remove it in a methodical manner. Upstands are a little bit different. You need to use normally mechanical hand tools at that point as well. And then finally, when the existing coatings are off, best method we've used is recirculatory blast equipment, which will remove any remaining staining to give it a clean surface. So that's your preparation from start to finish. New concrete, abrasive blasting to remove the latents or any oil or any other residue that's on there. Existing concrete, you take off the existing coatings using mechanical means that aren't going to damage the concrete. Be careful of expansion joints, be careful of bridge furniture, drainage outlets, etc., etc. And then abrasive blast to final clean. Steel, new steel, you're going to check compatibility with the holding primer, abrasive blast using recirculatory blasting thereafter, upstands open blast, existing steel, removing the existing asphalt, and coatings using mechanical means. Again, not to damage the bolts and the rivets and welds that I talked about before, to provide a clean surface that's free of contamination, any existing residues and any latents on concrete. All of those are very important. The final thing I'm going to say is about weather. You need to watch when you're doing preparation and before the waterproofing starts is about weather. And weather conditions are very important, that they are checked before, during and during the testing stage later on. Most systems need to be applied at 4 degrees and rising. There are a few that can be applied down to freezing and below that, but please check with the manufacturer that it is possible to do that. There won't be any adverse side effects from applying it below 4 degrees, and that in any event there's no ice or frost on the concrete or the steel. Temperature is one thing, humidity is another. Certainly if you're on steel, you need to watch the humidity. Humidity and dew point need to be checked. Typically speaking, on a concrete deck, if the dew point falls within 3 points of the air temperature, stop work. If it's on steel, it's 5 points. At that point, moisture will start forming on the surface. And if you apply over moisture, whether it's a bitumen, acrylic, polyurethane, polyurea, Puma system, or whatever variety, you will get blisters. You will get problems with delamination. So it's not a good idea. Your installer should be aware of it, but as an engineer, you should also be aware of it to make sure these checks are done on an hourly basis to avoid any adverse effects later down the line. So in this section, we have covered surface preparation on new, old, steel and concrete surfaces, and also the weather conditions for acceptable installation. One final part about masonry. There aren't many masonry structures, but they come few and far between. On a masonry surface, again, it's got to be clean and dry, but obviously there's going to be sections where the brickwork is that need to be treated. Generally speaking, you need to make sure that the surface is flush pointed. So you're applying onto a smooth surface, and that the brickwork is abrasive blasted to remove any loose residue, any spalling brickwork, and that everything is flush pointed to give you a uniform surface. So preparation is similar, apart from you actually filling in the mortar joints flush before you apply the system. But generally speaking, the rules are the same. It needs to be clean, dry, and free of any loose materials before you apply. So hopefully that's going to give you a fairly good idea in terms of preparation before you start the waterproofing. Any more questions, please ask. But thank you so much for listening. Thank you. Bye-bye.